What's up, guys? Welcome to the 7th lab for JWTs. I was confused. I thought it was 6, but we are doing the last two, authentication bypass via algorithm confusion, and then via algorithm confusion with no exposed keys. This was kind of on the side, and I read up on it after I created those videos and wasn't aware that there was kind of two more labs relating to JWTs, JSON Web Tokens. So if let's just get straight into reading it and kind of going over what we learned here. So, algorithm confusion attacks. Key confusion attacks occur when an attacker is able to force the server to verify the signature of a JSON web token using a different algorithm than is intended by the website's developer. If this case isn't handled properly, this may enable attackers to forge valid JWTs containing arbitrary values without needing to know the server's secret signing key. Interesting. So now we get introduced to symmetric and asymmetric keys. Symmetric keys are a key that can be used to both sign and verify the token. And asymmetric key consists of a private key, which is used to sign, and a public key, which is used to verify. So, make sure, integrity, make sure that nothing's been changed. And privacy, confidentiality, I think that's how you say confidentiality. Make sure that all the data is kept, secret, and it's, yeah, just overall making sure that it doesn't change. So, as the name suggests, the private key must be kept secret, but the public key is open shared so that nobody can verify, so that anybody can verify that the signature of tokens are issued by the server. So, how do algorithm confusion vulnerabilities arise, we may ask? And we can see here that algorithm confusion vulnerabilities typically arise due to flawed implementation of JWT libraries. Although the actual verification process differs depending on the algorithm used, many libraries provide a single algorithm agnostic method for verifying signatures. These methods rely on the algorithm parameter in the token's header to determine the type of verification they should perform. So here, if the algorithm is RS256, it will use the provided key as an RSA public key. And if the algorithm is HS256, the provided key as an H secret key. So I'm guessing if it's HS256, it'll use it both as the private and public key. Rather, if it's RS256, it'll just use it, publicly make sure that, verify the signature. So, problems arise when the developers, I cannot read. When the developers who subsequently use this method assume that it will exclusively handle JWTs signed using an asymmetric algorithm like RS256. Due to this flawed assumption, they may always pass a fixed public key to the method as follows. Verify token public key, okay. In this case, if the server receives the tokens signed using a symmetric algorithm like HS256, the library's generic verify method will treat the public key as an HMAC key. So here it's going to verify the token using the public key, but if we change the algorithm from RS256 to HS256, it's going to use the same key to verify, verify and sign the key. So that's why it's dangerous, an overall interesting attack. So, performing an algorithm confusion attack, we have 4 steps. Here we have to obtain the server's public key. 1, we have to convert the key to a suitable format, create the malicious JWT, with the modified algorithm, and then sign the token with the new key that we created. So, step 1. Service, and we're gonna kind of go do this in steps and not just do it all in one shot. That way we kind of understand where we're going and what we're doing as each step proceeds. So servers sometimes expose their public keys as JSON web key objects via standard endpoint mapped to JWKs at JSON or well-known / JWKs JSON. For example, they may be stored in an array of JWKs called keys. Okay, so let's kind of access the lab right here. Our proxy isn't on. Let's delete this. My account. Did I burp? Like, Is it not responding? Oh no, never mind. Okay, so now we're gonna go to Wiener, Peter. Wait, can we actually access it from here without logging in? Let's save this and access this via URL. And here we are, an exposed JWK, having you know, the kid here. We have the algorithm used. We have everything used. So that is step one. We obtained the server's public key. Now, step two, we have to convert the public key to a suitable format. So it says that first we have to create a new RSA key in the dialog. So we have to paste this new key. Let's go to this and let's delete these both, and let's create a new RSA key by inputting this. Well, let's okay. Well, no, let's grab this part, let's copy this and then click OK. Now if we read it, now select the PEM radio button and copy the resulting PEM key. So let's copy public key as PEM. Go to the decoder tab. We can kind of get rid of this. And then we're gonna encode as base 64. And let's copy all of this. Encode the PEM, go back to the JSON web token editor keys and create a new symmetric key, because we are aware that it uses a symmetric format, right? So let's do some new symmetric key, and we are going to generate. Now here it says replace the generated value of the K parameter with the base 64 encoded PEM key that you just copied. So let's replace all this with this base 64 encoded string and click OK. Now that it is saved right here, OCT 3608. Once you have the public key in a suitable format, you may modify the JWT. So we're going to go to repeater and let's log in here. Let's go back to login. Wiener, Peter, let's turn intercept on. Let's allow this to forward. Change this to admin. We've been through this a couple times now, and send this back to repeater. Now, so wait, let's use this one. Let's change this to administrator. And now what we want to do is also change the algorithm to HS256 instead of RS256 like we just read. Now we just have to sign this using the public key we just created and send over the request, and we have a 200 OK response. Let's copy this original here and let's copy this key. Also, let's turn off intercept, and we can delete the user Carlos. Let's replace this JWT with the new one we created. Right here. And the user was deleted successfully. So we were able to bypass authentication, by switching the algorithm. We were able to get the public key. We converted it to a format. We base encoded the PEM key, and then we put in the K parameter. We got a new public key. We modified our JWT with the new algorithm, and then we signed it using the public key. So the server uses the public key to verify and sign the token, because it is using symmetric symmetric and not asymmetric, it's using symmetric algorithm. So This means that the server uses a single key to both sign and verify the token. So, thank you guys for watching. This is the 7th video. And the next one for sure is going to be the last one, where we are going to be talking about algorithm confusion with no exposed keys. So it's going to be cool learning. It's going to be cool learning how that how that whole process works. Thank you guys, and stay tuned for when we finish messing with JSON web tokens for now and move on to a different web attack.